Hello, everyone, and good morning. It is 10:30, so I'm going to go ahead and get started here with the welcome. I see we already have 150 people in the room and counting. Over 300 of you have signed up for today's event, so we are so excited to get such a wonderful turnout for this really wonderful program. So my name is Anna Volker. My pronouns are they, them, and I'm the Executive Director of the Aspen Science Center, as well as SciAccess, which is one of the organizations hosting today's event in partnership with the Ohio State University Department of Astronomy. So at 10:40, so in just 9 minutes, the astronauts will go live from the International Space Station and start answering our questions. As a little bit of background, the questions they'll be answering have already been sent in. So if you're sending questions now, feel free to do so, but for the astronauts, they'll actually only be answering the questions that were pre-sent. We had about 50 people send in those questions by the deadline. So thank you so much to everyone who sent in questions. Many of those came from students at schools for deaf and blind learners all across the country, as well as students involved with SciAccess and our mentorship programs. So we're so excited to get that wonderful turnout and to hear what the astronauts have to say today from the International Space Station. Today, after that segment, we will have an additional special Q&A with our guest speakers who are here with me now. So I'm going to go ahead and actually let our guests just introduce themselves briefly before we go ahead and get started with the astronaut section. So to start off, I'll give everyone a brief introduction to George. George Whitesides is one of our key collaborators for Mission Astro Access, and I'm so happy he's here today. He is the chair of the Space Advisory Board for Virgin Galactic and was the company's first CEO, and over the course of the last 10 years served in this role, bringing it to successful spaceflight operations. He was also the chief of staff for NASA under President Obama and Administrator Charles Bolden. George, welcome. Thank you so much for being here today.
Thanks, Anna. It's a great pleasure to be here.
Thank you so much. We're also joined today by Dr. Amy Sardone from Ohio State's own astronomy department. Amy is a National Science Foundation Astronomy and Astrophysics postdoctoral fellow at Ohio State and researches the formation and evolution of galaxies. Amy, thank you so much for being here.
Thanks for having me. I'm excited about this.
Awesome. And last but certainly not least, we have Dr. Anna Mosquera, who is an astrophysicist associate at the International Lunar Observatory Association, where they are getting ready to launch a mini telescope to the lunar surface in early 2022. Anna is extremely passionate about space exploration, and in 2019, she participated in an analog astronaut mission through NASA, Campaign 5, Mission 2, where she was in isolation for 45 days, preparing for a simulated mission to Phobos at the Johnson Space Center. In 2020, she was selected to join POSSUM as a scientist astronaut qualification program participant and is actually currently working on her application to be considered by ESA for one of the European astronauts. So welcome, Anna. Thank you so much for being here.
Hi, Anna. Thank you so much. Thank you for having me.
Thank you. I'd also like to give my students a brief moment to introduce themselves. This is not a one-person operation by any means, and I've been working very closely with two students, Caitlin and Michaela, who made this possible. So Caitlin, would you like to say hello?
Absolutely. So hello, as mentioned, my name is Caitlin. I currently am a sophomore at The Ohio State University, going on a junior. I'm very excited to be here. I've been working with Anna for about a year now. And am very excited to see our questions answered today.
Thank you so much, Caitlin. And next, I'd like to give Michaela a moment to introduce herself. Michaela actually submitted this proposal with me to the NASA Johnson Space Center all the way back about a year ago. So Michaela, thanks so much for all of your work on this.
Thanks, Anna. Hi, everyone. My name is Michaela Deming, and I am one of the interns at the SciAccess Initiative, and I also recently graduated from Ohio State with a bachelor's in astronomy and astrophysics. And as Anna said, I helped draft the application for this event all the way back in August. So I'm very, very excited that it is finally being realized this morning. Thank you, Anna.
Thank you both so much. So to give you a little bit of background on what we'll be doing, in 5 minutes, what's going to happen is I'll actually share my screen, and we're basically considering this a Zoom watch party. We'll watch together as the astronauts get online and live answer our questions from space. That segment will be 20 minutes long and will take place from 10:40 a.m. to 11 a.m. Unfortunately, they will not be able to get to all of the amazing questions you submitted, but that is why we have our awesome panelists here. So we'll do our best to try to address some of the questions that they don't get to. And just because we have so many folks here, we won't be able to get to every single one of your questions, but we'll do our best to answer everything we possibly can. If anyone is having any issues with the screen share, I've also shared the link here to NASA TV in the chat, and you can actually watch that directly. So if you'd like to open that up independently, feel free to do so, but I'll actually be sharing my screen, so we should be able to all watch it here in the Zoom chat. I see we have a few, wow, wonderful questions pouring in already. So we'll be sure to get to those after 11 a.m. when we have our International Space Station friends sign off. And just a couple accessibility notes here. As you see, we have a live ASL interpreter on screen. We also have live captioning through a CART captioner. So if you would like to access that, be sure to just click the CC button at the bottom of your screen, and you should be able to access that. Caitlin and Michaela will be helping monitor any questions and messages. So Caitlin and Michaela, feel free to let me know if anyone is having any technical issues, and we'll be sure to get that sorted out. So without further ado, I'll go ahead and get our screen share set up so that we're ready for the ISS when they begin.
Station, this is Houston. Are you ready for the event?
Houston Station, we are ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
We hear you loud and clear, ACR.
Please stand by for opening remarks.
Hi, my name is Kendall, and I'm from Bloom Carroll Middle.
Hello, my name is Anna Volker, and my pronouns are they, them. I am the Executive Director of the Aspen Science Center and of SciAccess, an initiative dedicated to promoting disability inclusion in STEM. I am so excited to be hosting today's event in partnership with the Ohio State University Department of Astronomy. SciAccess and Ohio State have been working closely together to form Zenith, a mentorship program for blind high school students from around the world. I am also thrilled to announce that the newest SciAccess project, called Mission Astro Access, is now accepting applicants with disabilities to become crew members in a weightless parabolic flight that will launch with the Zero Gravity Corporation later this year. The long-term goal of Mission Astro Access and of today's call is to help pave the way for disabled space explorers. Today, you will hear questions from our Ohio State Zenith scholars, from members of the broader SciAccess community, and from students and teachers at schools serving blind and deaf learners from across America. For all of our blind and low vision audience members tuning into today's program, I'd like to start things off by asking our astronauts, what do you and your surroundings look like? Please describe yourselves and your environment. Thank you so much.
Hey, thanks for having us. We're glad to be with you today. I'm Shane Kimbrough. Today I'm wearing a light blue shirt with black pants. Our pants have Velcro on them because we stick things on them all the time, otherwise they go floating away. Thomas here next to me, Thomas Pesquet from France, is wearing a gray shirt and gray pants with Velcro on them as well. We put our iPads on there quite a bit because that's where we have our procedures, and it just tells us what to do throughout the day. So we kind of slap those on our thighs where the Velcro is. We are in the U.S. laboratory to describe our surroundings, and there's all kinds of equipment. We have a bunch of cameras next to Tama here because there's a nice window just down by our feet that we get to look at planet Earth a lot and take some really nice pictures. To my left here is what we call, this is one of our cardio machines that we work out on about an hour a day or so. It's a floating bike, but it's called our stationary bike. And then there's lots of cables and computers around, other science racks that are next to Tama, and a glove box next to Tama as well. And this is where we do a lot of work during the day with science and research.
Hi, my name is Kendall, and I'm from Bloom Carroll Middle School in Ohio. My question is, can astronauts have low muscle tone as a physical disability like me?
Right now, we don't, but there's been a lot of research on the space station about muscle, because astronauts experience muscle loss over the course of a 6-month mission. So we're looking into what's happening to try and improve all the therapy and the conditions for people on Earth suffering for those conditions. In the future, we don't know what's going to happen, but for now we have to exercise every day to keep our muscles strong, because otherwise we would lose our muscle tone during a 6-month mission.
Hi, my name is Noah. I'm 13 years old, and my question is, what happens when you mix baking soda and vinegar in outer space?
Well, that's a good one, Noah. They don't let us do that on the space station because it would be a real mess for sure. If you did it outside, like in outer space, I don't know if that's what your question's getting at. That'd be tricky, I think, just to be able to try to do it, because the vinegar would probably evaporate out there. It's a vacuum, so it'd be really interesting to see what would happen. But to my knowledge, nobody's ever tried it yet.
My name is Charisse Hine. I'm speaking for my student at the Ohio School for the Deaf. My question is, suppose radio transmission from astronauts is lost. Do they know sign language in order to communicate?
It's a great question. We don't learn per se sign language, but when we're outside in our spacesuits doing a spacewalk, if we lose the radio, then our only means of communications are going to be visual. So we have a set of signs that we're using to say stop, go, continue, everything is fine, or things are not going well, and lots of other technical terms that we have that we agree on and that we use between us. Is kind of a code. So as such, it's kind of an embryo of sign language. And yes, we're using this, or we would be using this if we lose our radio transmissions outside of the space station. Inside of the space station, we can usually talk to each other, but we're also using a lot of nonverbal communication because it just makes our days easier and more efficient.
Hello, my name is Vincent. My question to you guys is, I know you guys are in space for extended periods of time, but how is the oxygen cycled in order for you guys to breathe? Thanks for your time.
Thank you for your question. We have a really good system up here that's almost honestly like it is back at home if you're in your house or in a school environment with the air conditioning system. But we have oxygen tanks that are on the outside of the International Space Station that can feed oxygen in so that we can breathe. And then the systems inside here just make sure that the percentage levels of oxygen and nitrogen and other things are exactly correct so that we can just cruise around here without a spacesuit on while we're inside the space station and breathe normally.
Hello, my name is Matisse. This is my sign name. I am from MSD, the Maryland School for the Deaf. I have a question for you. I am curious. Can astronauts who travel to space play Roblox online with me?
We don't have a real internet connection. I mean, it's getting better now. It's my second mission. You know, it's like at home, the internet connection gets better, but we're not really directly connected to the outside world. We're connected to NASA on the ground, and then they connect themselves to the internet. So we have a small internet connection. We can have emails and phone calls, but we don't have video games right now. Maybe in the future, you know, things always improve, things get better. So maybe in the future, you know, our downtime, we can play online video games, but for the time being, it's not the case.
Hello everyone, my name is Megan Jordan, a student at the University of Alabama in Huntsville and a member of the Patty Grace Smith Fellowship, a program that connects Black undergraduate students with jobs and mentorship in the aerospace community. Today I have a question submitted by Stokely at the Marie Phillips School at the Learning Center for the Deaf. Stokely says, what are you guys currently working on?
We are very busy almost every day, as you might imagine. This week I'm working on our water processing facility because it went down, or it broke about a week or so ago. So we've got to get that back running again so that we can get our water processed correctly, so that we can have food. You know, we put a lot of water into our food so we can have that to eat, and then we can have clean water to drink. So that's taking up most of my time, and other folks are working on science experiments and other maintenance activities on the space station. And of course, we always work out, like Thomas was talking about earlier. We work out about 2 hours a day, about an hour of cardio and about an hour of resistive weightlifting exercises.
Hi, my name is Soteris. I'm from Massachusetts. I'm very curious. I know you guys are very, very busy on the space station, but I wonder if you're able to take a break. So you're working all day, then you finally get a break. During your break, what do you do? Do you do nothing at all, or do you have specific activities? I'm really curious. Let me know.
Well, you know, it's a good activity. It depends. Some of us, you know, we might have some hobbies that we like to do. We take a lot of pictures. We also have, you know, some recreational activities. We have some sports ball up here. So everybody's really free to do what they want in their spare time. But some people write their diaries. Some people, you know, read. Some people just film something to remember those time on space station. Those are very special times that you want to remember. So it's really up to the individual. Sometimes we do group activities, and sometimes you just float and you just watch the Earth go by, because it's one of the most beautiful things you could possibly see. So there's a lot of things you could do on the space station over a course of a 6-month mission, and you need sometimes to take a break and to think about something else than just work.
Hello, my name is Michaela Deming, and I am the president of the SciAccess Zenith Mentorship Program, which provides mentorship and astronomy education to blind and low vision students in middle and high school. I have a submission from one of our Zenith scholars, JT from Pennsylvania, who asks, will SpaceX make regular crewed flights to the International Space Station?
Yes, they will. We are the second operational flight called Crew 2. That's what we flew up here about a month ago now. And they're going to plan on having about 2 per year for the next few years. So it's really great to have SpaceX and the Crew Dragon flying us up to the International Space Station.
Hello, everyone. My name is Dom, and I'm from Cleary School for the Deaf on Long Island. I have a question for you. Can a deaf person become an astronaut?
It's a great question. Currently, no, there's no such thing. But you know, you never know how things can evolve. If you remember the astronaut from the 60s and the 50s, the 60s and the 70s, sorry, they probably couldn't imagine that today you could have LASIK eye surgery and you could make your eyesight better, and you actually can become an astronaut even if you're not born with a perfect vision. So hopefully things evolve in that direction. And we're looking into it at ESA. We have a project to evaluate evaluate, what it would take to send somebody with a handicap in space. So it's something that will happen in the future, not just right now, but in the future. I'm convinced this is going to happen.
Hi, my name is Caitlin, and I'm an intern with the SciAxis Initiative from Columbus, Ohio. I'm currently in the process of advocating for the inclusion of a deaf astronaut on a future NASA mission, so I wanted to ask, how do you deal with extremely noisy environments aboard the ISS?
Thanks for the question, Caitlin. Thank goodness we don't have many noisy environments up here in general. Now, there's always fans running in the background, but it's a very low decibel level. And we have people on the ground, the safety team, that makes sure that anything that comes on board the space station isn't going to hurt our hearing or impair our hearing. So we have some safety measures. If we do have to do something that's going to be loud, then we're hearing protection. We've had to do that a few times since we've been here when we were off-gassing some oxygen bottles. But besides that, it's pretty normal up here. We don't have to have hearing protection, and the decibel level is nice and safe for all the astronauts on board.
Hello, my name is Michaela. My sign name is MJ. I am from the Maryland School for the Deaf, the Deaf Institute in Maryland. I want to ask you, my question for you is it fun in space?
It's a good question. It is a lot of fun in space. We can float. We can be upside down. We have crew members that are actually being funny as we speak. You see a lot of balls flying around. So there's a lot of things that you can really do to make the most of the weightless environment. We work a lot, obviously, but we also like to have some fun sometimes. So it's really cool to be in space. It's exactly what you think it would be. It was my kid's dream, and we're having a ton of fun with the crew.
My name is AJ Green, and I am a student at the Ohio State School for the Blind. I am in the 3D modeling club, and my question is, do you guys have 3D printers at the International Space Station?
We do have a 3D printer up here, and on our last mission, Tama and I, that thing was cranking out something several times a week. It's slowed down a bit, the pace, but we did have something that got printed. It's actually a filter that we're going to use here on the space station pretty soon to help one of our systems that wasn't working so well. So it's great to have that capability on board, and now we're actually using it to make parts for the space station.
Hi, my name is Lindsay and I'm from Ohio. My question is, given that the ESA has begun recruiting para-astronauts, what are some ways to make the space station accessible for people with impairments of all types?
Yeah, it's a great question, and indeed, as part of the next astronaut selection happening this year and next year for ESA in Europe, we're going to be looking at hiring people with disabilities, and then those persons will work with ESA, with the partners, with NASA, with our Russian colleagues, Japanese, Canadians, and our industrial partners, SpaceX and others, what it would take to send those people into space. Right now, like so many things on the ground, unfortunately, the spacecrafts are designed for people who have no physical disabilities as part of the astronaut selection, but this has to change. It's changing on the ground. It's going to change in space as well. It's going to take some time, but the good news is we're looking into it. We're actively looking into it, and starting this year, that project will aim to bring a person with a disability into space in an outlook of 4 to 5 years. So I think it's going to be a great project to be part of.
Hello, everyone. My name is Andrew. This is my name sign. I was recently a student who volunteered in a webinar project for NASA's GLOBE program. Today, I want to ask you a question about your actual experience traveling to space. I did some research online and found that your height increases by 1 inch when you go to outer space. I want to ask you about your real-life experience as an astronaut. Is it true that when you travel to space, your height increases by 1 inch? That's all. Thank you.
All right, thanks for the question. It is true in most cases. Everybody's a little bit different, I would say. Sometimes people get up to 2 inches taller, which I did on my first flight, which I was very happy about because I finally got to 6 feet tall. But that's the only way it's going to happen for me. We haven't really measured ourselves this time to see how many inches or centimeters we grow. Tama, he works in centimeters over here because he's from Europe. So we got to be looking at those units of measurement as well. But we do grow because your spine expands, right? There's no gravity holding it down, so it just expands a little bit, and sometimes that's 1 or 2 inches.
Hi, my name is Sarah. I'm from Battleground in Washington State. I live there. I'm really curious. Why did you want to become an astronaut? I'm curious.
It's a great question. I wanted to become an astronaut because I was as passionate about flying, about everything, seeing the Earth from above and being among the clouds and having this view and this feeling of flying was just my passion. I became a pilot. Shane was a pilot too, so it's very common, but it's not the only way to become an astronaut. I was also looking at doing something useful, not just something that's good for me, not just something that's selfish, but I truly believe that being an astronaut and doing some research, doing all the research we do on the ISS benefits everybody, benefits humanity. We're doing this for the people. We're not doing this for ourselves, even though we like doing it. So I think combining those two aspects was really great. And I think being up here, you're really freed from all the constraints of the human body, and that's what floating is actually. It's you don't have a weight anymore. Everything is easy. Everything you can fly, you can float around. It's really you're freed from all the constraints of the Earth, and that's a fantastic feeling. You feel like you're a superhero. You have superpowers, and that's something we love. So that's why astronauts always want to fly to space, and once they've been to space, they want to fly again.
Hi, my name is Izzy. I live in Colorado. I have a question for you. What is your favorite kind of game to play in space?
Yeah, thanks for the question. We don't have like games maybe that you would have at home. Like we don't have board games or anything around here. It'd be very challenging to have pieces because they'd all be floating around. You play some kind of inside joke games sometimes with each other just to have fun and goof around. But other than that, and like Tama talked about earlier, we don't have video games to play with our systems, at least ones that can interact with people on Earth. So we got a little growing to do in that capacity. My favorite game, if you call it a game, is just looking outside the window at planet Earth. We do that a lot when we have a little downtime.
Thank you so much to our amazing astronauts and to NASA for creating this important opportunity. Thank you to our community for sending in such insightful questions. I have no doubt that there are many future space explorers among you who may someday be on the other side of this call. Thank you to the Ohio State Department of Astronomy and the OSU Center for Cosmology and Astroparticle Physics for partnering with us on this exciting event. Thank you to the Patty Grace Smith Fellowship and the Brooke Owens Fellowship for advancing diversity in aerospace. To learn more about the Mission Astro Access Parabolic Flight Opportunity or the virtual SciAccess Conference taking place this November, please visit sciaccess.org to connect with our community. Thank you, NASA, for sharing our commitment to making space for all.
Station, this is Houston ACR. Thank you. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.
Amazing. I'm going to go ahead and stop my screen share now so we can get back to our questions. Thank you so much for everyone who sent in a question for this program. All right. So I see we have a lot of questions in the chat here blowing up, so that's wonderful. Unfortunately, the astronauts obviously have to go back to doing their jobs in space, but that's okay because we have 25 more minutes here with all of you and with our wonderful guest speakers. So I'm going to actually start by pulling up some of the questions that were sent up as videos to the space station that might not have had a chance to be asked. So let me just pull this up here. So one of the questions we have that didn't get addressed is from Michelle Clark, who asks about water in space. So she wants to know how water works in space, how, you know, folks do things like wash dishes, actually drink water, clean your hands. How does water work in microgravity? So I was wondering if, Amy, would you be interested in addressing that question for Michelle?
Sure, I will try. I have not been to space, so this is just from what I know, and I can be corrected if I'm wrong. I know that there's a lot of really cool equipment on board that does recycling. With water, you have, you know, of course, you have 2 hydrogen atoms and an oxygen atom. And so one of the things that they do with water is they use electricity to separate those atoms from each other, and then they can recycle them. They can, you know, separate the 2 hydrogen atoms from the oxygen atom and make more oxygen for the astronauts to breathe. They can then take the carbon dioxide that the astronauts breathe out, and they can do the same thing where they separate the carbon and the oxygen and combine that oxygen with the hydrogen atoms, and then you get H2O again, right? So you have water. You start with water, you breathe, and then you end up with water. So that's one of the things that they can do on board. As far as like washing dishes and things like that, I'm not so sure about that, but I do know that they use water to kind of rehydrate their food. A lot of the food comes up to the space station having been freeze dried or dehydrated, and that kind of, I think, helps with preservation and weight.
Awesome, thank you. And I'll say here too, if I call on your question, feel free to use the raise hand icon, and that way you can actually maybe ask it yourselves or add anything onto it that we might have missed. So if you hear me calling out your question, feel free to raise your hand and one of our tech supports can actually unmute you. But next up, we actually have a question from Ohio, a student named Nicholas, who asks, how can I become an astronaut? So Anna, as we mentioned earlier, you're actually in this process both as an analog astronaut who's done missions here on Earth and as someone applying with ESA, which is the European Space Agency. So can you talk a little bit about that process that you're currently doing right now?
Hi, Anna. Sure. After the guest that you have, you know, I'm very humble to make any comments or talking about this. I dream about to go to space. And I watch when ESA made the announcement, and the first thing that they say, like this amazing astronauts, is if you think that you have like the check marks of what it's you know, like the basic requirements, don't be shy, apply and let ESA judge you. Don't judge yourself. So that's basically, you know, what I'm doing. As I say, humble by all these people that are so talented. I assume I have the basic requirements to give it a shot and to enjoy the process. The process for ESA is lengthy, as is also for NASA. The deadline is May 28th, so I'm fine-tuning my documentation. That is not that much actually in this first stage. And then there are like 6 stages. As I said, it's a bit different from NASA. In the case of ESA, it's 6 stages. And the first one is just to send your CV, a motivational letter, and some documents. It's the passport, and then the it's a pre-med related to the pilot's medical. They accept the United States FAA one, so that's the one that I got because I live in Seattle, Washington. And that's basically all you have to do. And when you go to the webpage, you fill an online questionnaire that it's not lengthy at all, answering some basic questions. And then you wait, and one step at a time. The first screening, I don't know, there's not a specific time for that, but I assume there may be like 2-3 months to for this first stage, and then a psychological, a medical, and a couple of interviews with different panels. And I think that Isa General Director at the end, at the very end. So that's it.
And we actually have a follow-up on that from Niklas, who asks, what type of computer programs would it be useful for me to learn if I'd like to go to space? So as someone applying for that process, do you have any insight on what programming languages our students should learn?
I don't know. I can just, I cannot give too much spoilers, for example, from some stuff that we did in the analog mission, which it was very exciting because some of the parts of the Hera spacecraft were replicas of the shuttle or of the ISS doing that maintenance that the astronauts were mentioning. And we have some projects in which we actually had some little programming related to some tiny rovers that we were handling. In that case, for example, things were in Python. I think that any language that you are, I'm actually an astrophysicist that work a lot on computing. So, and as an amateur, I'm not a software engineer or anything. But I think that once you know one, it's sort of very easy to move and to be flexible. So any programming language that you have the chance to learn, it's gonna be useful, and you will have the ability to move among and learn, always learning.
Amazing, thank you so much. Next question I have is from Jose Lopez, who asks, are astronauts able to see and track environmental degradation from space? And how does this help prepare for life on Mars? So George, I know you have done a little bit of work with GIS in the past, is that right? So maybe you could help field that question for Jose.
Sure. Yeah, I think it's a really good question. And I think that the answer is that you can see deforestation from space. And particularly if you have a little bit of a telephoto lens, you can see where humans are impacting a forest environment or a rainforest. And so that is definitely possible. And I think more broadly, using space as a way to analyze our Earth is going to be really important over the course of the coming decades. And so by looking down at the planet from space, we can learn a lot about the atmosphere and about how life, plant life is doing. And those are going to be really important measures as we deal with the challenges of climate change. So I think it's a great question. Thank you.
Thank you. And we have a follow-up here, actually, kind of to a similar effect from Joshua Strayer, who mentions that I know that Earth has a lot of non-renewable resources. So do you have any input on some resources that we could find outside of the Earth to help offset that? George, or maybe Amy, do either of you have any comments on that?
I can jump in and maybe Amy can add. Yeah, I think it's a really great question because there are enormous resources in space. There are enormous mineral resources in space, so different elements in the asteroid belt or on the moon are available in huge quantities. There's also a lot of solar energy in space. The big challenge with both of those things is getting those resources down to Earth, which is the expensive part. And so we need to keep working on the cost of space access and how we would, do something in space and then bring it down to Earth. But as the question implies, being able to access the resources of space may well help humanity in the future, which is an exciting prospect.
Absolutely. Absolutely. Thank you so much. Next question is for Anna. One of our students, Joanne, who's one of the Zenith scholars, asks, how do you manage being away from home and loved ones for so long? And so, Anna, I know you haven't gone to space quite yet. You have essentially done that as part of the isolation you had to do for your analog missions. So maybe you could speak to that a little bit for Joanne.
Sure. We were just in isolation for just 45 days. And when you compare this day with, what astronauts have done that have been there for almost a year, it's nothing, let's say, compared to what they have done. But I think that to deal with isolation, in my case, there are like two components. One is like the goal. I'm extremely thankful for the opportunity that NASA gave me to participate in the project. And it was extremely cool because you can put like your 2 cents in a space exploration from being a subject. That idea of contributing to the whole space exploration program is just amazing. And if, I don't know, one day my dream of going to space becomes a reality, there's also like the part of the adventure, right? It will be like an amazing experience. You help humanity, and at the same time, you're having the time of your life, a lot of fun. So when you have such a goal, I think that things, and I don't want my family to be mad, but being away from the family, it helps you to overcome that thing that it's a challenge. And I think the other component actually is your family and your support system. My family is amazing. My friends that are like the family that you choose are also amazing. And when you have like that support, they are going to be holding your back when things go right and when things go wrong. It's also encourage you and make things easy. You know that they are going to be okay if you're away, and that is a worry, right? If you're away, you cannot communicate. As in here, we only have like half an hour to communicate with family and friends once a week, which actually the astronauts, I think that they can do. I think that they can go home if they want to, or they have the time. I'm 100% sure. But when you have a very specific amount of time to communicate, it's like, well, it's my mom going to be doing all right? Are things at home going to be okay? So if you know that, for example, that they have also their bubble, their support, and that makes, that gives you peace of mind. So those 2 components, you're an amazing goal to help people and having an adventure, and an amazing support system that I'm lucky to have at home.
Amazing, thank you. I have a question here that I'll give to Amy from Nikayla, who asks, how do people eat and do really anything in space when there's no gravity? Amy, I think we lost you for a second. Can you hear us still? We'll give her a minute. Looks like her video might be frozen. That's okay though. We have lots of questions to get through. Oh, there we go.
Sorry. Yeah, I froze. Can you repeat the question?
Absolutely. Yeah, it's from Nikayla, who wants to know how people could eat or really do anything in space if there's no gravity there.
Well, I suppose one of the ways that people move around and do things when there's no gravity or microgravity is just part of physics. You're pushing yourself one way or another. And so you can continue to do that when you're in space. You just don't have anything pulling you in one direction necessarily.
Right. Awesome. Thank you. We have another question here, which Amy, I'm going to throw to you as well. It's from Sophia, and she wants to know, how do people breathe in space?
Well, I think we talked a little bit about oxygen with the astronauts as well, but there are, you basically have to bring it with you. There is no air in space, right? It's a vacuum, and so we need air to breathe. You have to carry it with you. So any oxygen that the astronauts are breathing has been taken to space. I believe that the atmosphere inside the space station is pretty similar to what we breathe on Earth, which is mostly nitrogen and some oxygen. Yeah, they continue to kind of replicate what we have here on Earth. Like I had mentioned before with the recycling, they can, take sweat and other wastewater and even urine and remove oxygen from those liquids, and they can use that to recycle and continue to have air to breathe.
Amazing, thank you. Next question here I'll give to George, and it's from Kirsten, who asks, how do rockets lift off?
Well, basically, you have some kind of reaction, combustion reaction, where you're creating high pressure inside of a rocket engine, and then the gas is expelled at very high speed out of a rocket nozzle, and that is kind of pushing the whole ship upward at very high thrust. You may have played with, water rockets, which kind of work on the same principle of developing some high pressure inside of a soda bottle or something. And it's actually basically the same thing. You're just, developing, high pressure that pushes the rocket up. So that's kind of how it works in summary, but there's a lot of great videos online that get into more detail if you're interested in that.
Awesome, thank you so much. We have another question here that I'll actually field from Jordan, who wants to know what kind of food do you grow in space? So Jordan, I used to work at the NASA Kennedy Space Center, and there they run something called Project Veggie. And this is actually a NASA project to grow food in outer space, and it's something they're doing right now. So they grow all types of plants on the International Space Station as we speak. And then at NASA Kennedy Space Center, they have a special chamber that's an exact replica of the chamber they grow on the space station. And so they use that to do research. And a really cool thing about Project Veggie is they actually use students to help test different plant species all across America. There are middle and high school students just like you who are growing plants in their classrooms, and they create their own Project Veggie chambers, and they actually help NASA collect really important data. So that's something that I think is really awesome to know. It's something called citizen science, which is when students and members of the public can actually help do that research. And so I'll actually just drop a link in the chat here if anyone wants to learn more about how that works. You can look in the chat. Next, I have a question from 7-year-old Jordan, who says, if the universe began with the Big Bang, where did those materials come from? How did nothing turn into something? I think this question has Amy written all over it. So would you like to help tell Jordan about the Big Bang?
Sure. I think, one of the things that nobody really understands is the nothing into something. What we don't know what happened or what was around, or if anything was around, of course, before the Big Bang. And so at some point there was just a singularity that explodes, and that has created basically everything that we see and know about. Yeah, I think that's the short answer.
Awesome, thank you. We have a really interesting question here from Marcelette, who wants to know how many deaf staff are working at NASA. So Marcelette, I don't have a specific number to give you. I can tell you I've worked with multiple deaf people who are employed at NASA, including multiple deaf engineers who are working at NASA right now. So they definitely do have deaf staff members working there. How many? I can't say offhand, but I have worked personally with multiple deaf individuals who are engineers at NASA. So that's a great question. Next question I'll give to Anna. Nicholas, who's actually another one of our Zenith scholars. So Nicholas, it's great to see you here. Nicholas wants to know, how do astronauts have to be strapped down while in the spaceship or while on the space station?
You mean like, you have to clarify the question. You mean like tight? Please.
Yeah, no problem. Oh. I think he's wondering, do they have to, secure themselves?
Okay.
Yeah.
As far as I know, they do it when they go to sleep.
Right.
And I think that's the only occasion in which they do it. I don't know yet. For example, they have described, and that's something that I think that it's always funny when they describe how to use the toilet, for example. I'm not sure how that may work. It seems that it's complex, and that may require some help, I would say. But then that occasion, and when they go to sleep, they strap, yes.
Right, and actually you can, if any students are interested, you can look that up and see videos of NASA
Yes.
astronauts basically in little pods, sleeping bags that Velcro to the walls. Because otherwise you would just float around while you're sleeping and you could maybe bump into something. So that's really
Yes.
important. And it is a good okay here, so let me look back at our list. We have a question from Angel who wants to know how many years ago was the space station built? So Angel, I'm happy to field this one for us. It actually took 10 years to build the International Space Station and over 30 missions. So it was built in parts. An analogy I like to use, it was basically like building with Legos, where you took all the individual pieces and had to build them slowly over time. This process started all the way back in 1998, but as soon as 2000, we've actually had people living on there. So for over 20 consecutive years, there have been humans living on the space station all the time. I have another question here. Someone wants to know how many people. This varies. It's typically around 6, although right now there's actually 7. So although we only talked to 2 astronauts today, they're actually in a crew of 7 people. So there's actually quite a few people up in space right this second. So really great questions. Let me see here. Wow, so many good questions. I'm gonna go with one from Yar, who asks, I was wondering, how does the sun look and moon look from space? Does it look different than it would look from the Earth? Amy, would you like to answer that one for Yar? Oh, I think her video might have frozen on us again. Well, while she's frozen, maybe either George or Anna, would either of you like to help answer, how would the sun and moon look different from outer space?
Well, I don't know directly. You can, everything's probably a little brighter in space because you don't have the Earth's atmosphere reducing the sunlight or the moonlight. But you talk to the astronauts, so it's quite bright during the day or when you're in the sunlight. But I've heard that looking at the moon is actually really, really spectacular from orbit. And just incredible. And you can see some of those pictures as the space station is circling around on the night side of the planet and looking out at a moon that's lit. It's just a spectacular view. So I think that's one of the things that people will love to see when they go up into orbit. But Anna may have some other thoughts on that.
Yeah, I think that's great. Anna, is there anything you'd like to add to that?
No, I wish one day I can see that and I can give that feedback. But I'm sure maybe pretty spectacular, as George has said.
Absolutely, thank you. I have a question here. One of our students asks, has there ever been a blind or low vision astronaut? Is that possible? So far there has not, but that's something that we would like to change. And that actually connects really well to the project George and I are working on with the whole team of collaborators called Mission Astro Access. So this year we'll actually be doing a parabolic flight, which is when you don't go to space, but rather fly an airplane up and down and parabolas, and you create a microgravity environment. So we're doing this year with the partnership of a group called Zero G. And long term, we'd actually like to go to space itself and to help pave the way for astronauts with disabilities. So that's something we'd like to see change in the near future. And we are getting close to our time, so I'll end here with one final question from Deborah, who asks, how can we stay connected to this project? Wonderful question, Deborah. We would love to have you all stay connected. And what I can do for everyone is put you all on our email list to stay tuned about updates with this project. So you're all already set on that front. But in order to learn more, you can actually visit sciaccess.org, which is the website that was mentioned during the ISS broadcast. And this is a place where you can learn about our different initiatives and connect with us, not only for Mission Astro Access, but for a conference we're hosting this November. We're hosting an annual conference that is all about promoting access to science in general. So we'd really love to have you all join us there. With that, I am going to close things off for today since we are at 11:30, and it has been quite an eventful hour. So thank you so much to everyone for joining for this program. We really appreciate all of your questions, and we're so excited that you're all able to join us today. Thank you to Amy, Anna, and George for spending time as our special guest panelists, and to joining us and the International Space Station astronauts to help answer some of these questions. Awesome. Thank you all so much. I hope you have a great rest of your day and that we can see you all soon. Take care, everyone.
Thank you, Anna. Bye, everyone.
Thank you.
Bye-bye.
Thank you.